2.50 is a polynomials and functions. So this is the rational zero test or the rational root test. The idea is sometimes you have a polynomial like this where there is no trick to factoring. You can't factor this by grouping, trinomial. So what do you do? So there's this thing we call the rational root test. So imagine that that's your P and this is your Q. So if you list out all the possible factors of P, so your factors of P are plus and minus 1, plus and minus 3. So these are all the numbers that can multiply to be 3. Positive 1 times positive 3, negative 1 times negative 3. And your Q is 2. So all the numbers that multiply to be 2 are plus and minus 1, plus and minus 2. And then from that, they said, if you have your possible factors of P and Q, if you divide them, you get your possible answers. So if 1 divided by 1 is 1. 1 divided by 2 is 1/2. And then if I do 3 divided by 1 and 3 divided by 2, then I have my all my possible roots. So what that's saying, if there is a rational meaning a number that does end, for example, 1/2, 12. If you do have a number like that on the graph, it should hit one of these points. So you just had to check. I like to just check the whole numbers first. So let's say I'm going to check the positive 1 version, and we can check that with synthetic division. So synthetic division, I get a 2, 5, 5, negative 3, and a negative 3, and I get the 0. So if you get a 0, that means that you found one of the roots. So remember that when we do synthetic, it's opposite. So this tells me that this polynomial can be factored into x minus 1. And then these comes together, and they are 2x squared plus 5x minus 3. And then now we got to see if we can do other things that we do know. So for example, here we can just ACB this. This is a simple ACB question. So this is 2x and x. This is 3 and 1, positive and negative. You can do your full ACB. That's just my shortcut. I'm going to do my ACB. So now I have 3 factored parts. And now we can do it easily where we say x is equal to 1, x is equal to 1/2, and x is equal to negative 3. So this is a trick to find your nice roots. Let's do another one real quick. Again, this is your P, this is your Q. So if my P is 25, then I have a 1, a 5, and a 25. Those are all the numbers that can multiply to be 5. Q is 2, so I have a plus minus 1, plus minus 2. And then my PQ is plus minus 1, plus minus 2, plus minus 5, plus minus 5 over 2, plus minus 25, and plus minus 25 over 2. Again, I want to check with the nice numbers first before I go to the fraction. And it's usually always the smallest numbers. So I'm going to check a positive 1 and see what happens. So 2, negative 15, 23, 15, negative 25. Bring down that 2. So I have 2, negative 13, negative 13, 10, 10, 25, 25, 0. So I chose 1 and it worked again. So again, this tells me that I have x plus 1 or x minus 1. And then I have this. So this is 2x to the third power minus 13x plus 10 plus 25. And I can't factor this by grouping. I can't do anything. So just run it again. Notice that this is 2 and 25 again. It's not always going to end up perfectly like what we started with. So it's the same set of P and Q, so let's just run it again. I'm going to test 1 again. Bring this down, 2, 2, 11, negative 11, negative 11, negative 1, 1, or negative 1, 24. So that didn't give me a 0, so that means 1 is not the right answer. 1 is not a root. I'm going to try, let me try negative 1. So this is negative 2, negative 15, positive 15, 25, negative 25, 0. So that tells me that this is a root. So this is x plus 1. And then I still have my x minus 1. And this is 2x squared minus 15x plus 25. And I can ACB that. This ACBs to, I think I can ACB it. Let's see. 5 and 5. And then minus, minus. So then I have my 4 chunks. So then my zeros are x equals 1, x equals negative 1, x equals 5 over 2, and x equals 5. So if you cannot ACB this, if you can't ACB this, you have to use the quadratic formula. Okay, so I believe 28, you won't be able to ACB it, so you're going to have to use the quadratic formula. So part of the homework is this. The idea with this is once you have your roots, use what we did last time and graph. Right, so if I was to graph this one, 1, negative 1, 5 over 2, it's about there, and then 5 is over there. So just knowing that it's a power of 4 is going to come this way, it's going to end that way. It's going to go through everything. All right, so on 31, 33, you are to graph it.